Hi everybody, welcome to day 4 lesson on second derivative test. The reason we were doing all those multiple derivatives on Friday, one of them was so we could evaluate the second derivative. The second derivative helps us to determine the concavity of the graph and if there are any inflection points. So the first thing I'd like you to do is to complete the information as it relates to the first derivative below the graph. So the question in this section, this is all I'm asking you to do right now, is to determine if the first derivative is positive, negative, or zero for each of the following x values. Please remember our previous lessons that if the slope of the tangent line at a point is positive, the graph is increasing and the derivative would be positive and greater than 0. And when the graph is, when the graph is decreasing, the slope of the tangent is negative. And when you have a slope that is 0, at this point you have a relative maximum or minimum. In this case, maximum because the graph is increasing to that point, to the left of the point, and decreasing to the right. So that's a relative maximum. So that information you should be able to fill out as a review. So pause the video, do that, and then we'll come back in a few seconds. Okay, I hope that worked out for you. The next thing we're going to talk about is concavity by using this graph as an example. The first time you heard about concavity was probably when you were graphing parabolas in the 8th grade, and one of the things we noted was they were either concave up or concave down. And when we get into more advanced higher degree polynomials, there are multiple places of concavity changes. So if you look at this graph, for example, it is concave down in this section and then concave up in this section and then concave down again and then concave up. So the concavity is changing. And what we're going to use our second derivative for is to evaluate what is the concavity and where are those points where the concavity is changing. Because I can tell that the second derivative, when the graph is clearly concave down in this pink section on the far left, the question is, where is this change? At what point is it changing from concave down to concave up? Where is that specific point? Okay. Those points where the concavity changes are called points of inflection. In the graph below, 0, 0 would be a point of inflection because the graph is concave down on the left of it and concave, oops, I never changed colors, sorry, and concave up on the right side of it. The second derivative test will tell us the possible points of inflection where these changes take place. They occur, those points are when the second derivative equals 0 or if the second derivative doesn't exist. So very similar to our first derivative test that tells us increasing, decreasing, or a relative extrema when it equals 0. It's kind of the same basic principle. We have a point of inflection where the derivative is equal to 0, the second derivative equals 0, or the second derivative doesn't exist. Test for concavity. If the second derivative is greater than 0, the function will be concave up. Please remember that greater than 0 equates to being positive and less than 0 equates to being negative. When I spell that out, sometimes it is as if I'm stating the obvious. However, in the problems on the homework you're going to see, and in Delta Math, you're going to see a lot of examples where they just say the second derivative of this function is greater than 0, and some of us aren't thinking about how that greater than 0 really translates to positive. Because when we say it's positive, kind of gives us a lot more, I don't know, something triggers in our brain a little bit better than greater than 0. For me at least, maybe not for you. Okay, so there's two problems here. I'm not going to do all the work involved in the two problems. So I'm going to explain to you the second derivative test and how to do it. And then I'm going to leave the first derivative test on the left side of the paper to you to determine the extrema for this graph. And I'm going to show you the second derivative test. So you will do the work to find the extrema. You could pause right now, and you could do that now, and then come back to the video and finish up with the second derivative test. But you should be practicing that first derivative test, finding your critical numbers, setting up your intervals to test on, test if that first derivative is greater than 0, less than 0, or equal to 0, and then deciding where your function is increasing or decreasing. Okay, then we go to the second derivative. So at that point, either after you've paused or if you're going to do it after I'm finished everything, that's fine too. The second derivative for this function is, using the power rule, is 6x. And then I set the second derivative equal to 0 and solve. This is a pretty easy one. I get x equals 0. So 0 is my critical number. Use that critical number. Find a test point on the left side and right side of it. You may have more than one critical number if you have a higher degree polynomial. If that happens, then you're going to do your, remember my B's, before, between, and beyond. So you're going to test points in all those areas, and then you'll find out whether your function is positive or negative. If you look at my work here, I plugged in -1 was my test value in the interval from -infinity to 0. I choose -1 as my test point. The second derivative of -1 is -6, and that's negative. So that means that my graph is concave down before I get to 0. And then I plugged in a test point from 0 to infinity of 1. The second derivative of 1 is 6, which is positive. So the graph is concave up from the interval from 0 to infinity, which means that the point x equals 0 is an inflection point. Okay? So now I'm going to find out what the actual coordinate of that inflection point is. And this is something we have been forgetting to do. We've just been saying, oh, that's a relative max, or that's a relative min at x equals this, and not finding out what the y coordinate of that is. So make sure you do that on the first part of this problem. So plug the value you get for the inflection point 0 into the original function, not back into the derivative, not into the second derivative, not into the first derivative. Find out what is the value of the function at 0. So we're going back to the original function here, substitute in, and we get f of 0 is -5, which means 0, -5 is an inflection point. Now, one of the things that this lesson says to do is to verify your information graphically. Now I know that if I put this into GeoGebra, I can easily see where the functions intervals, where the maximums are and where the inflection points are. That's true. Well, if you know how to do it, it's true. But I want you to use it as a tool to verify. You don't have me here with you now to say, you're right, keep going, you're right, you have a sign wrong. So we're going to use GeoGebra really as a tool in understanding. So I'm going to open up a split screen for you here, and I have the function already inputted. So the function is here, and I just want to show you the GeoGebra commands so that you can check your points. So when I'm in input, I have to have my, have to be ready to input something, and you hit the three dots that are in the bottom left of the screen on the top of your input section of the calculator, the commands come up. Now, we really haven't used them yet this year. You might have used them last year, I'm not sure, but let's check our extremum, which you calculated during the pause. And after you hit extremum, you're going to hit F for the function. This is the function f of x here, and you can check to see if the extremum points that you found out in the beginning of the lesson were correct, at -211 and at 2, -21. And then if you go back to those commands, again, the inflection point is a command. If you just start typing, yours aren't going to come up as fast as mine because I've used them before. So you just start typing extremum or start typing inflection, okay? And it'll come up. It starts eliminating things you don't want, and that'll come up. And then you just tell it of the function f in case you have multiple functions in, and there's the point 0, -5 that we just found out. So I'm going to leave you with finishing the question number 1's, finding the algebra involved in finding the relative max and relative min, and then the complete finding of the extremum and inflection points for function 2, and there is some homework for you to do on Khan Academy. It's a couple of multiple choices. I got tricked once, so I'll give you a little pointer. It says mark all intervals that are correct. So once you find one interval, don't just say you have the answer that you're finished, because you're going to see there's more than one right answer. So it's not truly multiple choice. You have to go through each choice. So check that out. All right. I will be available to you on Google, on email. And what I'd like to do is set up a date this week that we meet during our class period. I don't know what day it's going to be, but one of the days. So if you have anything pressing, you want to pick a day, maybe Wednesday, I'm going to say that Wednesday or Thursday we're going to meet as a class during our class time, and everybody check in at that time. So stay tuned for that. That's coming up on Wednesday. All right. I hope all is going well. Email me, send me a remind. You can also send a message in the classroom app. If you don't understand something, my office hours are 9:30 to 10:30 and 12:30 to 2. I'll be happy to get on live with you and do a chat and figure stuff out if you're struggling. Otherwise, give me some feedback and let me know how this is going for you. Have a good one. Thanks. Bye.